Hey, I thought it might be cool to show you how I build a single-handed Xbox One controller. So I'm going to show you. So this is the model controller that came out in 2016 when the Xbox One S did, which was the slightly improved Xbox One that had a 4K Blu-ray drive. You rip off the back decorative panels, which are actually harder to remove than they used to be, so maybe they had problems with them falling off in people's homes. Then you desolder the rumble motors. There's actually rumble motors in the triggers on the Xbox One, so yeah. Then on the front of the unit, you can see we have the analog sticks, which we'll just yank off right now, and all the buttons. The very first thing to do is to put this into the laser and etch it. Okay, there it is. We have some laser etching here and here, which we're going to use for reference points. So I'm going to drill two 2mm holes there for some mounting screws. 4mm hole. There and right there. That's for our wires to go through. Before I go any further, I'm going to bring this piece back over and just put it in place, and then just do a very light reference tap just until I see some black plastic come through. I don't want to drill it too hard because it would hit the circuit. Cool, now we have reference points. So this is going to be a right-handed controller, so the idea is removing all the controls to one side. In the case of these two buttons, it's the left click in and left bumper. So I'm going to score the plastic with my X-Acto knife, basically increasing the surface area for the glue. I'm going to go in two directions. Great. Now I'm going to use this cement for plastic models. I don't use super glue here because the super glue can seep up into the switches and cause them to seize up, whereas this tester's glue is more predictable. And also I never use super glue gel. I think it sucks. So I'm just going to put these side by side. Cool. So one of the things that we want to do with this controller is move the D-pad from here to there. I used to do it using one of these 5-way tack switches, but the problem with them is that they stick up above the surface of the controller, which means they have a propensity to break. So we do it a different way now. Okay, so here's my new custom D-pad solution. There's a 3D printed base, a custom made circuit board which has the buttons on it, the D-pad cross itself, and finally a cap. Here's a piece of thin ribbon cable. I'm going to flail both ends of it. It's 5 conductors, so up, down, left, right, ground. One trick I like to do if I flail wires like that is I'll come in with a pair of scissors and snip them across the top again. That makes them all level, because when you flail them, they have a little bit of an arc. Alright, so what I'm going to do here, so I'm going to take these wires and put them into the vias. I'm going to hold them in place and then make sure they're all in. Okay, once I can feel that they're all in, I'm going to do this. I'm going to bend the wire back and then press in like that. That applies pressure, which keeps them in place. Now I can flip it over and solder it. This is one of those situations where you definitely run out of hands. So I've got the solder suspended in midair, and I'm going to bring the piece to it. Get it all heated up, make sure the via flows. I'm going to do the ones on the side first, that way it holds the rest in the middle firm. It's kind of like when you're screwing boards together, you always screw two opposite corners, then the middle. Yeah, so I'm just bringing the board to the solder. Just want to make sure that the solder is all the way around the wire, otherwise we might have a cold solder joint, but yeah. Looks like we made it. Okay, now I'm going to take our D-pad base and put in some more model glue. Not a whole lot. The main thing here is I want to make sure the PCB stays flat. so the buttons engage correctly when you push them. There's a crescent-shaped slit that the wires go through. Then we just compress the PCB against it. And I'll just squeeze it for a minute to allow the glue to set, and then we'll set this aside to let it dry. Okay, while the D-pad dries, we can come back to these two buttons. Now these are surface mount tack switches, but that doesn't mean we can't solder them manually. So I'm going to come in on the side, make sure I tin the connections, just like, ooh, not like that. Happy little connections. So on the older controllers, like, I don't know, 5 or so years ago, we would have tack switches on the inside, standard tack switches. But the problem with that was when you pushed on them, they would fall through the controller. By having these on the front, when you're pushing on them, you're pushing your effort against the controller shell itself, which is not going to easily break. So I was actually worried about these tack switches being the point of failure on this model of controller, but they ended up being okay. As I mentioned before, the point of failure ended up being the tack switch D-pad. So I spent a little bit more money and just got a custom PCB made. Now I'm going to use what might seem to be an overly long wire for this, but I'm doing that because one of these connections actually has to make a pretty good long trip inside the controller, as you'll see later. So again, it's left bumper L3 and then ground. So I'm going to take the middle one, middle ground, that's easy to remember. I have the high ground, Anakin. Now I'm going to tin it. Tinning it can affect the pliability of the wire, but this wire is so thin, shouldn't make a difference. I'm going to bring it through here, like that. A lot of times wire is like sewing, strangely enough. Okay, so see how I made that bend there? So I'm going to go over here, I'm going to push that bend against the pad, heat it up, and we should have a connection. Normally I have my face all stuck up in this so I can see it better, but obviously the camera, that's kind of the thing with the camera, especially with the show. It's kind of like the Heisenberg uncertainty principle. Like the fact that you're observing something can affect the thing you're observing. So I'm just going to double check this connection, because in situations like this it is possible to fuse the plastic of the wire to the plastic of the controller and it'll stay put and make you think you have a connection, but you might not. So to double check, I'm going to attach the lead to the other side of the tack switch, because you remember the tack switch leads are connected this way and this way. So if this beeps, it means we have a connection, which we do. Cool, so I'm now going to attach this wire here, this wire there, and this wire there, and this part will be done. Knock 3 times on the ceiling if you want me. Do, 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 twice on the pipe. If the answer is no. I guess like banging on ceilings and pipes was the 1960s version of Tinder. I always thought there were 3 people, Tony, Orlando, and Dawn. But it turns out it was just Tony, Orlando, and then someone named Dawn. Again, I'm going to bend the wire down a little bit so it's kind of, you know, biting down into it, so to speak. So that's another situation right there where I have to make sure I've actually soldered the wire, not the plastic. So on this side, I think what I'll do, I'll bend the wire, let's get a little bit more slack. This is going to be covered up anyway. So like that. Get it like that. Whoa, that wire went flying. Dun, dun, dun. Great, now I've got that song stuck in my head. Maybe the AI Pringles can play it. I won't say her actual name because then she'll respond. Okay, now I'm going to put a little hot glue right here just to kind of act as a strain relief at the opening where the drill hole is. Pat it down with some spit. I marked the right wire with a red line so I know which one's which later on. And then I've got this little piece of laser cut funky foam. Just going to put it in place. And it tells you what the buttons are. So you got left bumper and L3. This should be dry enough as well. So I'm going to come in here and make just a little bit of a V-slit on the hole that I drilled, just to make sure the wires don't get crushed, because the wires aren't as narrow as that. See? That should be enough. So I'm going to feed that through. And then the screw mounts on the 3D print should match up to the laser jig. I'm going to use these size 2 screws that are 3/16 of an inch long. Again, I usually have my face right over this, but the camera literally gets in the way. Alright, let's just fasten these screws through. Nice and tight. So they're flush here. See that? They're flush there. And on the inside, 3/16 gets you through all the meat of the plastic, but not past it, which means it won't interfere with the inside of the case once we reassemble it. I'm just going to put a little dab of super glue here just to help the threads basically be stuck forever. Cool. We're going to work on the inner part of the controller next. So we can just leave the D-pad. That's not really going to affect anything for a right-handed controller. Although in the left-handed version we actually move these buttons over here, but I don't have that to build at the moment. Okay, so on the inside here we see there's 2 circuit boards. Now the reason they did this was because, remember the awful D-pad on the original Xbox 360 controller? Well, that was because there was only 1 circuit board and it was at this level. So there's this like big thick stalk on the D-pad. So it was this big rotating stalk, like, and that's why it was so crap. But in this controller, they actually have a secondary PCB underneath, and it has the pads on it for the D-pad, and that's why the D-pad is so much more responsive on this controller. One thing they have changed, there used to be 2 interconnects between the boards, but now there's just 1. So they did that to save costs. There also used to be a Freescale controller and a wireless board, but now all of the microcontroller stuff is built into the wireless board. So yeah, definitely cost reductions were done on this controller, which makes it a little harder to mod, but not impossible. See how that's loose? That's actually really smart. See, it just pressure fits against the pads there. What's good about that is if the person's like yanking it and janking it, they're not going to destroy the vias because there aren't any. So this acts as a basically a, I don't want to say a strain relief, but it basically prevents yanking on the cord from damaging the inside. So yeah, really smart move. So what I do is I just put a little dab of hot glue on it, of course, and then just to keep it in place so I don't forget to put it back in when I reassemble the controller. Okay, so I'm going to use my iFixit kit and remove these smaller screws here. This part's a little tricky. You have to like bring that forward. See the plastic that goes around the USB port? The reason you had to do that is because otherwise if you don't, when you put it back together, the silicone membrane for the buttons might not be in the right place. Oh, if only the PlayStation controller were like this. So PlayStation controller uses a silkscreen conductive piece of plastic, very much like a modern keyboard. So all of the face buttons are basically plastic, and the circuit is a silkscreen. So it's impossible to solder to, whereas in the Xbox it's really easy. Every switch has an I/O wire and the other side is ground. This is what I was talking about. So I'm going to make sure I just put this back in here. Cool. Now that the circuit board's removed, I can drill the rest of those pilot holes through without damaging the circuit board. I actually drill those holes holding the controller above my head so the buttons don't fall out. Oh, take a look at this. This is how the D-pad works. It's kind of old school. This is actually exactly how the old Atari joystick worked. Let's see if we can lift this up. I mean, I don't want to destroy it, even though the person's not going to be using this side of the controller. But see, it's just little metal rings that have a slight curve to them, so when you press them, they click in and complete the circuit, which is exactly what's inside of a tack switch, actually. Alright, so now that I have those holes drilled, I can start to reassemble. You also might notice that I hot glued the rumble motors in place. Normally they're just held in place by the plastic around them, so I hot glued them in place so they don't fall out while I'm working on it. Alright, so let's get this back over here. Flip this upside down like that. Bring these wires straight up. I'm going to feed them through the two holes that I just drilled. There's your D-pad, and here are your other buttons. Straight down like this. So Microsoft was kind enough to leave a handy slit in the circuit board right there. So I'm going to take the D-pad, I'm going to flatten it, I'm going to move it this way, because remember, there's still an analog stick here, so we can't put any wires through there. Now I'm going to take this wire and put it through that slit. Oh, look at that! Slick as snot! You can see that the D-pad wires are not getting in the way of the remaining analog stick. Alright, so I'm just going to compress this together and then make sure it's lined up, and then I'll put the screws back in. The Xbox One uses Hall effect sensors for the analog triggers, which basically means it detects the proximity of a magnetic field and uses that to generate an analog value, which is actually the same thing the Dreamcast used. On the left-hand side, we don't need the magnet, so I'm actually going to remove it just to make it easier to solder some stuff. Roadhouse style! Ah, yeah! Pain don't hurt. Yeah, I can put that on my fridge. Alright, so now we have the 5 wires here for the D-pad, and the 3 wires here for additional buttons. Now, all over this board are test points. They're probably kind of hard to see, but test points are basically points where they can attach a bed of nails and figure out if the circuit is working or not when they test the controllers, which gives us a really good place to attach our wires. So I have a list of them on my computer in a diagram that I use to reference, although I've pretty much got it memorized. For instance, according to my sheet, the blue wire, which is the rightmost wire from the D-pad, this is right. And right in the test points is this little test point right here. So I'm going to tin it. Now I'm right-handed, so I usually always orient my work dependent on, you know, my handedness. Well, I guess my handedness never changes. So if I need to, you know, get at something from the right, I rotate my piece so the wire's coming in from the left so I can solder it from the right. I'm going to bias it down a little bit and then just heat up it in the pad. Boom! Surface mount soldering isn't that hard. Unlike making clicky thumbsticks, up and left are over here. These pads are a little trickier because there's some surface mount parts around them, so you want to make sure that you don't solder too much or expose too much copper and cause a short circuit. It won't cause the magic smoke to come out, but it will cause your control not to work. So I'm going to bend the wire just, you know, not necessarily the minimum length, but, you know, a reasonable length. Alright, so the wire's been tinned, the part's been tinned. So I'm going to come over here. I'm going to bias the wire down so it's solid strand, which means it'll remember. And then I'm just going to attach it to the pad. Now the middle wire here is ground. So ground is everywhere. So I'm just going to come over here and remove some solder mask. So you might see me using knives to cut wires as they're on the circuit board and think, oh no, he's going to accidentally cut a trace. And cutting a trace is actually more difficult than it might look. So I'm not usually too worried about cutting traces, because for one thing you have to cut through the solder mask first, which is the green stuff on top. Same thing, I'm going to loop this around, get the approximate length, X-Acto knife, clip, just like that. I make sure I don't use the tip of the knife because then it'll break off. Because you know I like my knife tips. Yeah, that doesn't really work. See, this is like actually brand new 025 pitch wire. And it actually, since it's new, the plastic jacket is in pretty good condition, so it doesn't really want to recede. But if you use like old hard drive wiring that's like 20 years old, it will recede, like my hair. Alright, so this one's a little tricky. See how I'm having to make sure I keep all the wires outside of the analog stick? So this one's not going to necessarily work with my right-handedness, but no biggie. There's also a surface mount resistor really close to the pad, so I got to make sure I don't short it out. So what I'm going to do here is I'm actually going to come in like this. I'm going to rotate 90 degrees. I'm going to rotate the wire 90 degrees, attach it to the pad. Then I'm going to bend it down to clear the analog stick. Then the final one is left. So I'm going to loop it around here. I'm going to use this inductor as a loop point. Again, rotate to match my handedness. I'm unfortunately not ambidextrous. That might be a bit too much wire. I'm just going to cut it a little shorter. Make sure the lead doesn't end up in the controller. And see, if I had an 8K camera, I could just zoom in on this digitally and you'd be able to see it. Okay, now we have to hook up the left bumper and left clicky buttons. So right now we just need left bumper. So that's going to be the left wire and the middle wire, and the third wire, this will go around to the L3 connector later on. That's why I made this wire longer than it looks like it needed to be. So here's the left bumper tack switch. Let's see. So the center is ground and the left side is the I/O, so I'm going to do it like this. Cool. Alright, so I'm going to just bring this here. I'm going to keep it flat, keep it out of the way of the other wires. But I'm basically making sure I don't add any more than one wire thickness to the whole board, because I don't want it to interfere with the battery case. What's the old adage? You get what you pay for. Yeah, you know, sometimes you can get good cheap stuff. Like, I usually get monoprice filament. It's pretty cheap, and I've never really had any issues with it. Although, who knows, maybe it is filled with ball bearings and shavings like they say it is. Alright, so the mounting points of a tack switch are going to be ground. So that's the ground. There's basically ground everywhere. Maybe that's why they call it ground. Your dentist's name is Crentist? Maybe that's why he became a dentist. What TV show was that line from? Leave your thoughts in the comments below. I need to desolder the left analog stick and put it somewhere else. So, first thing I always like to tell people, the best way to remove solder is to add solder. Alright, got one of these. This one's pretty easy. Just push the button and the vacuum pulls out. So, it's not even a fancy Heiko. I don't know, I just prefer using these kind. So when I'm desoldering, I like to rotate it around and then pull to one side and then pull the trigger. Because usually these connections will be centered in the via, but not necessarily. So the reason I pull to one side and then let go is so it doesn't get stuck to the side of the via. You want there to be basically like black hole around it. Your favorite Roddy McDowell movie. If they'll ever remake that. Oh, who am I kidding? Of course they will. So yeah, if you can see a black hole around the pin, that means you've desoldered it properly and the pin is not touching the sides of the via. The plated through-hole vias, there's plating all the way through the PCB, which means it's like a whole tunnel to which solder can stick. So if you don't get the solder out of that hole properly, you're going to have trouble with the pin. Even still, you usually can't just pull it off with your fingers. You usually need to go in with a screwdriver and give it a little bit of love. It came out pretty easily. So that Hall effect sensor there, that's a surface mount part. So to get rid of it, I'm just going to heat it up. No, don't go that way. It went back where it was. Come on. There we go. Okay, at this point we should do a test to make sure everything is still electrically working. So I'm going to take this board, put it in like that, make sure the analog stick is on the shaft. Okay. Then I'm going to press it together. So what I do is I just plug this into a computer with a micro USB, and then in Windows you can just look at the controller properties and make sure everything's working. Alexa told me that Roddy McDowell wasn't in the black hole, but look, there he is, Roddy McDowell, voice of the robot. I mean, it's one of those things like you hear the robot's voice and you're like, that can only be Roddy McDowell. Kind of like when you watch the movie Streets of Fire and all the music is clearly written by Jim Steinman, although he's not credited as writing the music. It's like, how could this not be Jim Steinman music? And then it turns out, guess what? It is Jim Steinman music! We really only have two things left to add. The secondary analog, basically we take the analog stick that was removed here and put it to the back of the unit, and the secondary trigger. Streets of Fire is quite the movie. Everyone should watch it. It's actually got a lot of people in it. Really young Diane Lane, Bill Paxton, of course. William Dafoe is the bad guy. Rick Moranis. And it's got a cool soundtrack too. Actually, there's a song from that movie you've probably heard, but you probably haven't seen the movie. That song, it's like, I can dream about you if I can't hold you tonight. Anyway, that's from the movie Streets of Fire, although nobody remembers that movie, but I think everyone's probably heard that song. I'm going to mark this wire as ground, again, so I can keep track of what's going on at the other end. I'm going to bring this wire, go 90 degrees, come over here, and then it's going to go out the back of the unit right there. So we need to work on the rear trigger assembly now. So here it is, and it fits in right there. Alright, so a little bit of hot glue, just enough to hold it in place. Going to set it right there. For some reason I'm using all metric drill bits on these controllers, even though the screws are imperial. So I have a special screw for this trigger frame. It's size 2 screw, 3/8 of an inch long. Nice. This is a compatible Hall effect sensor that I think Felix found. Got a whole bin of them, and it's through hole, so it's easier to solder for projects like this. So what I do is I put a little bit of super glue there. I drop the bent part in place, and then I let it set. And on the back, I bend the pins over and put a little hot glue to make sure it stays in the right position. Also, I'm going to look at where the right side of the sensor is and mark the right pin down here. Here's all the parts that make up the trigger assembly. We have the trigger frame, trigger cap, 2 screws, a spring, and a 6x3mm neodymium magnet. So I'm going to take this test rig here, let the magnet stick to it, and now I know the orientation in which to install it here. Yeah, because the north-south pole of the magnet actually does matter when it's facing the sensor. Yeah, and the sensor actually reacts differently depending on if the magnet's behind it or in front of it. So the trigger has a little stop post on it right there. That keeps it from going too far. And the spring's attached. So we're going to stick the spring in here into the bottom of the trigger. There's a hole for it, and there's also a little recess on this piece. Goes in like that. We put the cap on like that. We shove this screw through. There we go. This screw also goes into the ABS plastic of the case, as you can see there. Cool. So we have the wires coming from the Hall effect sensor down there. So I've got to attach this in as little space as possible to where the Hall effect sensor was. Probably made it a little shorter than I needed to. There's actually a good amount of room inside this controller for your wire bundles and whatnot. Come in from the top. Oh, that hurt. I accidentally hit my finger with a soldering iron. Oh no, a horrible solder injury on my finger. I'll never type again. Cool. Okay, now I'm just going to take this 4-strand of wire and put it out the back through this hole that I drilled. Okay, with the wire in place, I can actually put the case back together. I cut a slit in this plastic so we can just slip the wire through it like that. This is the lower analog shaft. I'm going to put these 100 ohm potentiometers into it. These are the drift adjustment pots. Going to tin the leads. Now I'm going to just take some scrap wire. Now these are some fine wires, obviously, but it's inside of an enclosure, so they're protected. People want to feel like they're not different. You know, they want to feel the same. So I think by making an accessibility controller that is as much like a regular controller as possible, in both, you know, look and feel, is a good thing for people. Because if someone is in an accident or has a stroke or whatever might impair them, the most important part of the healing process is returning to the normal things that you love in life. And for so many people, that's video games. Make sure the 2 screw posts on the bottom are facing forward and back, so the XY is correct. So here's the signals coming from the circuit board. Here's our trim pot adjustment. So we're basically going to tie both of these to a little custom board that I've made, which looks like this. So this is what the removed analog stick is put onto. There's 3 screw points for this shaft, since it's the most likely to incur torque in any direction during play. People are really hard on controllers, you know, they throw them, they get mad. So the idea here is, see, the lower fingers can grip the shaft, and that one hits the trigger, and you're good to go. Maybe it's a good time to tell the story of why I build these controllers. Most of the stuff I build, or a lot of it, isn't my idea. People come to me and they're like, hey, I've got a problem, can you solve it? And then I figure out how to solve it. Yeah, 2006 I think it was. This guy emailed me and he's like, I just got back from the Iraq War and I lost a limb in one of those roadside bomb things. He's like, now I'm back home, but I can't play video games. And I was like, oh man, I never thought about that. But yeah, you need both hands to hold a controller. That sounds like a very interesting problem to solve. And so I came up with the first single-handed controller design. It was weird, but it worked. And then I started getting all sorts of other requests for it. So yeah, the first controller was for someone that was injured in a war. Since then, you know, obviously I've built them for people with a myriad of reasons. Stroke, birth defect, standard accident, but overwhelmingly, more than anything else, probably, well, of the people who email me first and tell me why they need it, not just the people who order it, but of the people that email me and like, here's my story, how do I order your controller? Easily, 33% motorcycle accidents. Oh my gosh, so my opinion of motorcycles has changed drastically. I mean, it's not like I was ever like into motorcycles, but I would never even get on one now. Never. After 12 years of every third email being the same reason why someone needs a controller. You know, the fact that I became known for doing controllers actually got me kind of the gig doing my video game latency monitors. It's like, oh, he does this stuff with controllers. Maybe he can help us figure out video game input latency. So I started doing that about 2 years after I did the first accessibility controller, and I'm still building those units 12 years later. First one ever was used on Modern Warfare 2. Yes. Yeah, see how bunched up this is? There's actually a decent amount of room in here to bundle up the wires, so oh well. It'll work. As long as everything's connected. That's what matters. There's a little shelf here that the controller sits on. That was always a running joke on the show, that as soon as you started filming something, it would stop working. And it happened so much. I didn't used to be superstitious until I started working with electronics and computers for a living. Let's put the D-pad in place. As you can see, this little raised portion which matches something on the cap to keep the orientation correct. This just snaps in place. Nice. And I'm just going to use super glue to attach a little decorative cap. That tells you what it is and where it came from. Okay, I've got it hooked up to the computer, so now I'm going to adjust these pots until the left analog indicator is centered properly. There we go. So you hold it like this. There's your left bumper and the right bumper, so you got 5 and 6. Then L3 is the same as clicking in on this. So we see that works. So we can go L3, R3. We see them both on the screen there. D-pad, up, down, left, right. Cool. Then the secondary analog trigger, so basically that is moved down there. Z-axis up, Z-axis down. Cool. I switched angles here so you can see the lower analog and how it works. So it sets against your leg and you move the whole controller against it. Up, down, left, right. That's why I inverted the wiring for it. Well, there you go. That is how I make a single-handed controller for the Xbox One.